I'd like to start by saying Ngati Gurujin and by acknowledging the Yarri traditional owners of Roebuck Bay, and I pay my respects to elders past, present and emerging. So as we all know here in Broome, Yarri are the perpetual authority on Roebuck Bay, always have been since time began, and we are so lucky, we are so lucky that we have had them as our project partner since the beginning. So, since the beginning of the Broome Community Seagrass Monitoring Project, this light demonstration is spectacular. Do you need the lights on?
Be nice to see you.
Should we pop the lights back on? Can you guys can see the slideshow with the lights on, hey? The benefit of having the lights on is you get to see me better as well.
Woo.
Yeah.
Yeah.
So, I would also like to say thank you to the amazing Grace, who is the coordinator for the Science on the Broome Coast series, which we're so lucky to have running here in Broome. It's such a fabulous science communication program. Thank you to Grace and the Roebuck Bay Working Group. So, ladies and gentlemen, sometimes the most important things are the things you can't always see. Weaving our world together is a thread in all the oceans of the world, rimming the shores of nations globally. This hidden thread is a hidden thread of power. The invisible thread I'm talking about, which is worth its weight in gold, ladies and gentlemen. The invisible thread which keeps our world intact is seagrass. And we have this treasure right here in Roebuck Bay, just over there, and we are so lucky. Yet most people don't know about it. Seagrass is usually always submerged under the sea. So people can't clearly see this matrix of gold spreading out across our bay, across the world, which delivers to us, humans, such a shocking quantity of value, an almost outrageous amount of benefit that supports our cultural and social and environmental and economic landscapes. So let me bring you in to our inner circle, this exclusive group of people in the world that know the secret, that really understand how powerful seagrass is. So let's take a step back and look at this incredible plant that forms these vast meadows under the sea. Like this. Wow. Right? Yeah. Right? Yeah, Malcolm knows. And like this, and like this. Feast your eyes, ladies and gentlemen. Isn't it gorgeous? And as you can see, it is like a glittering golf course out there at low tide. And if you can tear your eyes away, I know it's hard to look away. I know it's hard to look away from the seagrass. But what we're going to do is find out what this plant actually is. And the first thing I'm going to tell you is something quite surprising. Most people are very surprised when they hear this fact. Seagrass is not seaweed. I know, right? Not seaweed, different things. Seagrass has roots. It has an internal structure which is really different. Seaweed only has a simple hold fast, and seagrass has a vascular system, and they have completely different evolutionary histories. And I love to tell the story about how seagrass evolved. So while seaweed just hung out in the ocean like forever, seagrass was a little more adventurous. The seagrass one day long, long ago poked its head up out of the ocean. And what you need to understand about seagrass is it is always, always all about fun. It poked its head up out of the ocean and it looked over in the distance and it spotted something that looked more fun than what it was doing in the sea. Land plants, ladies and gentlemen. Land plants. And it said, I just think they look like they're having more fun over there, a better party. They decided to move onto the land, and this is a true story, they became terrestrial plants. They moved onto the land and they started to evolve, and they started to grow a root system and a vascular system and all those other things which make them, even to this day, much more similar to land plants than to seaweeds. Now, after a while, sea grasses decided to return to the sea. They wanted to return to their roots, and they wanted to bring their newly evolved roots with them. It was a rooty time back then. I'm talking about 75 to 100 million years ago. Now, I am very excited to share with you a new theory I've developed as to why the seagrasses decided to return to the sea at that time. I believe it was because of the dinosaur problem. Dinosaurs, ladies and gentlemen, were up and down our coast, especially around here in Broome, stomping up and down. And I tell you what, you can go anywhere in Broome to Entrance Point, to Ganthian Point, and you can see the evidence of the havoc they caused. The footprints. We've got footprints everywhere, we can see them, and I believe that this is why the seagrasses decided to make that move. I've not been stomped on by a sauropod personally, but I can imagine it's not a pleasant sensation, and if I was seagrass, I would want to go back to the safety of the sea as well. The dinosaur problem. You heard it here first, ladies and gentlemen. That is why, still to this day, seagrasses have a full root system, a vascular system, and this is the most delightful fact. This is a fact that makes my heart sing. They even have flowers. Flowers under the seawater. Have you ever tried to grow a flower under seawater? It's skill. It is skill. Flowers under the actual seawater. I've got this, now Malcolm, my boss, is here, he'll tell you, I've got this actual photo framed and it's sitting on my desk at work. Sometimes I gaze at it and get lost in the beauty of this sea.
Kiss it.
What? Don't share so much, Malcolm. It might not be that good for productivity, but it is a beautiful thing, a seagrass flower. And can you imagine how happy that must make our mermaid population? So that's what seagrasses are. But why are seagrasses so important? There are many reasons, and we're going to have to speed through them to get through them all. And now, you've heard of speed dating. It used to be a thing, right? I think it's been replaced by some app, Tinder or something. But speed dating was a thing. So what we're going to do is speed date all of the reasons that seagrass is important. So put on your perfume and your aftershave, ladies and gentlemen. Let's dive right in. Habitat. Seagrass is a very important habitat for fish, marine mammals, shorebirds, Fiona Wests, benthic invertebrates, and that means all of the sand-dwelling critters. Sea worms, sea snails, anemones, starfish, soft corals, the works. Number 2 is biodiversity. Oh my gosh, biodiversity. Guys, research shows that there are 20 times more animals occurring in seagrass meadows than on adjacent bare sand. And Roebuck Bay is one of the world's richest mudflats. That means it supports one of the greatest diversity of benthic marine species on Earth. Number 3, food web support. I tell you what, seagrass is so important in this area. You know, it's a primary producer, right? So it converts light energy from the sun into plant material, which then feeds the rest of the bay, and that means it feeds all the fish, the crustaceans, the marine mammals, the benthic invertebrates, which feed the shorebirds. And this extends to we humans that eat fish. So it has this essential role in the marine food web. Number 4, dugong. Dugong eat up to 40 kilograms of seagrass daily. 40. That's the equivalent of 60 iceberg lettuces. Now, I've got some vegan friends, I do. but I can't imagine them eating 60 iceberg lettuces in a day. They dig their snout into the seabed, and I'm talking about the dugong here, not my friends, and they uproot the whole seagrass. They eat the whole thing: roots, rhizomes, stems, leaves, flowers, seeds, the works. And when dugong eat seagrass, they leave these remarkable trails behind. And we get to see these trails when we go out seagrass monitoring. It's thrilling to think that just hours before, when the tide was high, there may have been families of dugong feeding in the very area where we're conducting our research. Now, here's something that's really exciting. I only just found this out last year, and Nyamaburiyaru country manager Dean Matthews was the one. He's an expert on these things, and he was the one he delivered this exciting news to me. And when I found out this exciting news, I had to drop everything and I had to call my nearest and dearest immediately. So I called my husband, and he didn't pick up the phone. Typical. And I was like, pick up the phone. I've got to tell you about this. He was out of range working or some excuse. When he got back in range, he had 27 missed calls, 16 text messages and big bold caps saying, call me. And he called me and he said, what? I said, are you sitting down? He said, yes, I'm sitting. I said, okay, this is big. This is big news. I have big news about dugong poo. He said, dugong what? Dugong poo. They found out. It was in Queensland. Baby. They analysed their poo and they found viable seagrass seeds. Do you know what this means? It means that dugong could be the seed-spreading birds of the sea via their poo. And it's improving the genetic diversity of seagrass meadows. There was a long silence on the phone. A long silence, and I get it. My husband was overwhelmed. He was overwhelmed with this big news. But look, it was true. There's a photo. How thrilled does the researcher look? She is holding a fine specimen of dugong poo there. Thrilling. Ladies and gentlemen, reason number 5 that seagrass is so important is turtle. Turtle also eat a lot of seagrass, up to 2 kilograms daily. And we often see these sea turtles. This sea turtle was out near one of our monitoring sites. Sea turtles actually have taught us humans something about seagrass. So scientists were tracking turtles via satellite, and they saw all these turtles stopping at this one little spot in the Indian Ocean in between Africa and Australia, rather. And they were like, why are they stopping there? There's nothing there. So they had a closer look. They found a big subtidal seagrass meadow that they never knew existed before. So the sea turtles helped the humans discover that. Reason number 6 is very, very important to Broome people. Fish and fishing and fish soup and rice. So, we've actually started a hashtag with our project. It's hashtag from seagrass, big fish grow. And that's to help share the message that seagrass is really important to help grow up those little tiny fish. And we see the little tiny fish in the intertidal puddles when we're monitoring. And it helps grow them up into the big fish. So it's a nursery and a breeding ground for juvenile fish and prawns and crabs. Reason number 7. Blue carbon sink. They call marine-based carbon sinks blue carbon sinks. And seagrass is one of the most efficient and cost-effective carbon capture and storage systems that we know of. Seagrass stores carbon 35 times faster than rainforests. It's extraordinary. So seagrass is really important to the health of our climate. And now down the coast, they have a different species to ours, but it's a really sobering real-life example of just how important seagrass is and how damaging it can be in terms of climate harm. So a few years ago, just down the coast, a place called Shark Bay, they suffered a massive heat wave. And it killed a large section of its seagrass. And when that seagrass died, it released no less than 9 million tonnes of CO2. 9 million tonnes. It's a lot of CO2. And I don't know why, but in Australia, we don't currently count carbon released from dying seagrass in our official greenhouse gas emissions reporting. But if we did, that Shark Bay seagrass death event would mean that Australia might need to change its figures upwards by more than 20%. 20% of our nation's greenhouse gas emissions from the loss of the Shark Bay seagrass. So you can understand why scientists and the media at the time described that death event as a carbon bomb. So seagrass is powerfully good at storing carbon, and seagrass death is incredibly dangerous for our climate and for our world. Reason number 8, seagrass aids water quality. It purifies our water, absorbs nutrients, and reduces turbidity. So if you like crystal clear, high quality seawater, you need seagrass. Reason number 9, seagrass absorbs pathogens. This is so interesting. Studies have shown that seagrass absorbs these pathogens. When I say pathogens, I mean germs. Waterborne germs, bacteria, and this includes human origin bacteria. So studies have shown that seagrass absorbs those pathogens and literally makes the water safer for we humans. It stops humans from getting sick, and it stops fish from getting sick from fish diseases too. So as I always like to say, a seagrass meadow a day keeps the doctor away. Reason number 10, seagrass oxygenates the water, and there's videos online of seagrass meadows literally bubbling oxygen out under the water. It looks so glimmery and pretty. It does look like, you know, the bubbles coming, rising to the top of a sparkling wine. So as we all know, oxygenated seawater is really good for keeping things in the sea alive. Reason number 11, seagrass stabilises sediment. Its roots hold everything into place, and it helps prevent erosion. Seaweed can't do that, ladies and gentlemen. Reason number 12, seagrass has an immense economic value. As a habitat, nursery, and through the food web support, it supports the commercial and recreational fishing industries, the pearling industry, and of course, tourism, which relies on a healthy environment. And different economic models come up with different values, but a conservative calculation is that a seagrass meadow is worth more than 20 grand per acre per year. So it's of great economic importance to people. Reason number 13 is a very special one in terms of our community monitoring project, and that is that seagrass is a very, very powerful bioindicator. And what that means is that by tracking the health of seagrass over time, we can get an ongoing indication of how the health of the whole bay is going. It's very handy. And this is why our Broome Community Seagrass Monitoring Project got started in the first place. Back in 2006-07, the community and traditional owners were starting to express concern around the loss of some species in the bay, like the iconic cockleshell. And there were also concerns about Lyngbia, which is a toxic cyanobacteria. And this inspired a call for a monitoring project to help keep tabs on the health of the bay. So after consultation with community, Yarru and scientists, it was decided that seagrass was the most effective bioindicator to run with to help our community monitor the health of Roebuck Bay. And so the Broome Community Seagrass Monitoring Project was born. And now we're coming to the end of our speed dating experience with all of these benefits of seagrass. And the final reason is that seagrass is so fascinating. In and of itself, it is innately fascinating. Let's just look how fascinated we all are. Fascinated. Let's just pick one aspect of seagrass to look at to demonstrate how fascinating it is. Let's look, I'm just going to pick it straight out of the air. Let's look at the sex life of seagrass. Yes. Now, you know how humans can reproduce in one standard way generally? No. What's that? Seagrass can reproduce in two ways. It's very clever and it's very creative. It's got some skills in this area. So let's start with asexual reproduction. So asexual reproduction, it's a solo gig, right? Nothing wrong with that. It's a solo gig, but it's basically self-cloning. So the plant clones itself and its offspring is genetically identical, same genetic code. So where this is crazy in terms of seagrass, in particular, is that it makes seagrass one of the oldest plants. So one seagrass plant, through this system, can become ancient, more than ancient. So in the Mediterranean, there is a seagrass species, Posidonia oceanica, and, okay, so wait, to get some perspective, you know how we've got old trees in the world and they can be hundreds of years old, and that's impressive? In the Mediterranean, there is a plant, and it is 200,000 years old. One plant living uninterrupted for 200,000 years. It dates back to the ice ages, to the Pleistocene. So it's crazy, but that's just seagrass's asexual reproduction. Wait till you hear about the sexual reproduction. It gets better. So sexual reproduction in plants is when the plants produce flowers, and seagrass is the only marine plant to produce flowers. And you've got your male flowers and your female flowers, and the pollen from the male flower needs to transfer to the female flower. How do you do that underwater? Seagrass does it in two ways, and both are fascinating. The first way, it is so romantic, you guys. The first way is that the male flower casts its pollen on the tide. It casts its pollen on the tide like a love letter in a bottle cast out to sea by a lonely sailor, dreaming of a beautiful woman. Just like that. And this male flower, it trusts that the forces of the universe, the tides pulled by the moon, are going to see its pollen sweep up against the waiting female flower, which has been longing for this miraculous moment. And fertilisation occurs. But there's something you need to understand about the pollen of the male seagrass flower. It's not your everyday run-of-the-mill pollen. It's something quite special. Seagrass produces the longest pollen strands of any plant in the world. The longest. So when these wash up against our lucky female flowers, you know there's going to be some fireworks, ladies and gentlemen. Not only that, but there is something else at play. In fact, I don't know what this does with the romance aspect, but there is someone else at play in this project, in this process. There is a third party. Seagrass scientists were filming seagrass under the water, and they saw on video something startling. Tiny, tiny crustaceans. And these crustaceans were transporting the flower from the male seagrass flower to the pollen from the male seagrass flower to the female flower, like bees do on the land. You know what this means? These tiny crustaceans are the bees of the sea. Fascinating. So all of this loving behaviour means that the seagrass flowers are able to get the pollen, and fertilisation can occur, and they can start to bulge with new life in the form of seagrass seeds. So I think that's been a pretty successful round of speed dating. Speed dating the reasons that seagrass is important. And look at that. Look at that. As we can see, the world looks pretty rosy with seagrass in it, right? It's a pretty impressive list of benefits delivered to our world from this plant. I mean, we wouldn't want to be lost of seagrass. You know, we wouldn't want it to disappear, because then it would take all of these benefits with it. Ladies and gentlemen, it brings me no joy at all to tell you something now which is not as fun and it's not as wonderful as what we've been talking about. Seagrass is dying out. It's dying out fast. Our world loses a soccer field worth of seagrass every half hour. A soccer field every half hour. I've been up here for half an hour. And that is another seagrass meadow gone. This is alarming, it is disturbing, and it is distressing. So around the world, seagrass meadows are disappearing due to human impacts, coastal development, physical destruction, dredging, pollution, sewerage, oil spills, coastal runoff, anchor and propeller scars, fertilisers and increased nutrients flowing into our seas from urban development, and causing the growth of these smothering algae and epiphytes. And in our local case, there has been the concerns about Lingdia. And all of these human impacts then combined with an increase in extreme weather events as well, mean that we are losing our seagrass at a terrifying rate globally. Seagrass is dying out. And when seagrass dies out completely, it's not pretty. It's not pretty. Dead zones can result. So in ecology, a dead zone is where all the oxygen has been sucked out of the water table, essentially suffocating everything in that area, the fish, the benthic invertebrates, everything. So these areas become like the ghost towns of the sea. It's like an eerie scene from a post-apocalyptic film. You don't want to look into a dead zone because you don't see anything. You don't even see a tumbleweed rolling along. It's eerily quiet and you get a bad feeling. Ladies and gentlemen, we can't let this trend continue. This is our world. We have children in our world. We can't let this happen to them. So what we need here, what we desperately need in this story are heroes. We need someone to step up. We need people to come to the rescue. And these heroes need to be smart. They need to know what's going on. They need to be dedicated. They need to be skilled. And they need to be really good looking. And so here's the good news. I found these heroes. They are hiding within plain sight, amongst us. There are some in this very room. It might be the person sitting next to you. I see you. I know your secret. They are amongst us, ladies and gentlemen. The heroes of this story are our citizen scientists, our seagrass volunteers, who are stepping up with passion, dedication. They're stepping up to look after our seagrass meadows here in Roebuck Bay, and they do that via their immense contribution to our community seagrass monitoring project. So these guys are everyday people. They've got their day jobs, they're hardworking mothers like Marissa over there. They're accountants, they're cleaners, they're surveyors like our John who always comes along, small business owners, mechanics, they're everyday people. And they walk around like they Clark Kent. Hey Roger, all mild-mannered and humble, but I know their secret. And they do have one particularly special superpower of their own. This is an incredible superpower, you guys. They have the ability to wake up very, very early in the morning to catch the early low tide so that they can access our seagrass meadows and do this important work. Amazing. Look at the earliness. So these superheroes are our cause for celebration, ladies and gentlemen. They are the heart and soul and strength of our community project. And the work these guys do for seagrass in our bay could not be more important. So how do they do this work? Let's have a quick look at how the magic happens. First, guided by Yaru, our community volunteers meet at a set time and place down at low tide at Roebuck Bay at one of our 4 monitoring sites, which are dotted around northern Roebuck Bay. So you can see here we've got a monitoring site at the port, at Demco Beach, at Town Beach, and we're so proud of our new site in the Marine Park, at a place we call Black Ledge. And then the most important part happens, the most important step. We eat freshly baked muffins, there's some here for you afterwards. And we drink freshly brewed excellent coffee, and it's got to be good. It's got to be, without seriously good coffee, ladies and gentlemen, ain't no one getting out of bed in the dark, right? So then we follow the GPS out into the bay, and it's a beautiful walk out, gorgeous. Over the mud, the tide is way out, the shallow intertidal puddles glow in the dawn light. And we get to our site and the GPS beeps. And we set up our transects, we set up our site, 3 lots of 50-metre tapes cast out according to the compass bearing. And then in our 3 teams, every 5 metres along the transect, we get right down and we start to monitor the health of the seagrass ecosystem. And we record everything. We record all the marine animals that we see in our quadrats. And one thing about our community group is that after more than 12 years of doing this work, we've got to know our benthic invertebrate population in the bay really, really intimately. So we record everything in the quadrat, right? Quadrat is a really fancy science name for square. We record all these animals, and we get to know that we get to know them so well that it stops being like wandering out and doing some science. It starts being like wandering out and spending time with your friends. So, I'll walk out there and I'll see my dear old friend, the green paddleworm, and I'll be like, GPW, what is going on? And then there's this guy, the Brittle Star. Now we've got a few different species of starfish out there in the bay, and most of them are quite elegant and graceful. They like to, move gracefully over the sand. This guy's got a real saunter about him, a real swagger, like he's really confident, but he's only a few centimetres big, so where does his confidence come from? I know where it comes from. The Brittle Star has the ability, if attacked by a predator, to discard one of its limbs as a defence mechanism. And we see this in nature, right? Lizards discard their tails and make a getaway. But the Brittle Star takes it to a new level. They can not only drop their limbs and grow them back later, they can also drop part of their stomachs and grow them back later. And if they need to, they can drop their gonads. Their gonads, ladies and gentlemen. Can you imagine what would happen if humans had this ability? Imagine you're just walking down the street and you're suddenly surrounded by thugs. Not a problem. Drop your gonads, chuck it like a grenade, make your getaway, live to see another day. All good. I think this is where the confidence comes from. They get to wake up in the morning and be like, I don't know what's going to happen today, but if I have to drop my gonads, I can just grow it back again. Brittle Stars, ladies and gentlemen, just one of the tiny critters with big personalities that we record and monitor in the seagrass ecosystem. Another little guy that's one of my favourites is the sea cucumber. Yes, these guys, look at that colour. They're often this colour out there, this beautiful pastel pink. The sea cucumber has a party trick of its own as well. The sea cucumber can breathe through its bottom. It can breathe through its bum. That's how they breathe. I don't know what the morning breath situation is like, but I think that's skillful. I think it's really skillful. So there are hundreds of these little creatures out there that we get to see during the monitoring process, and we get to know them all really well. But of course, we don't just record the animals. We also record the species of seagrass that we get out there, and that is mainly Halophila ovalis and Halogyl uninervis, otherwise known locally as the round one and the straight one. And I feel very passionately about these two little species. They're gorgeous. Here's a mix of them. So around the world, there's different species of seagrass, and some have really long leaves. Off the coast of Japan, there's a species of seagrass that has really long leaves, metres long. But our little species here are really small and petite, and sometimes good things come in small packages. So the leaves of the uninervis range from 2 to 6 centimetres, and the leaves of the ovalis, that's the round one, are about 1 centimetre. So we record the animals, we record the seagrass, and we record a range of other data, sediment types, seed sampling, the presence of algae and epiphytes, water depth, and we do all this following the standardised methodology of Seagrass Watch. And Seagrass Watch is a global scientific seagrass and assessment program. And we replicate this collection of the data inside our quadrats 33 times per site. So that's 132 quadrats of very detailed data collected across the bay per event. So this is an extraordinary achievement by our local community volunteers. And that is why they are the superheroes of this story of seagrass. The role they play is so important. And the data, once collected, is sent to the scientists at Seagrass Watch for quality assessment and control and analysis, and the information is then made available to anyone, but particularly to our coastal managers, so to Nyambaburi country managers, to DBCA, so that they can then make decisions about the bay with more confidence. So this is a community project to be so proud of, and everyone in our community gets to be proud of this, because this is also a project that brings everyone together. Traditional owners, local volunteers, community groups like Environs, Kimberley, scientists, government, industry, we are all brought together in support of this project, so we can all feel really proud of the work we do together. And as a community, it's really nice to think that we are not only supporting the thread that weaves Roebuck Bay together, but we're supporting the social fabric of our whole community, and our whole community is stronger and healthier for it. So what we've learnt tonight, ladies and gentlemen, is that there is magic in our world. There is magic in our world that supports life and well-being on our planet, and it takes the form of seagrass. And in an ideal world, the seagrasses of our world would be safe. They would be thriving. All the dugong of the world would have all the food they need. All the turtles would have all the food they need. The oceans would fill with fish because their habitat and their nursery and the base building block of the food web that supports them would be strong and robust and plentiful. All the benthic invertebrates would multiply and fill the bellies of the shorebirds that fly here to Roebuck Bay from as far away as Siberia. And the shorebird numbers would skyrocket. And in this world, the carbon from our atmosphere would get sucked back down safely and stored in the sediment in the ocean floor, and our climate would be safer. And our seawater globally would become so pristine in quality, so infused with those glittering oxygen bubbles, that all the dead zones in the world would fill up again with life. And the golden thread weaving our seas and our well-being together would not be unravelling, where every half hour we're losing another seagrass meadow. In an ideal world would be prioritising the safeguarding of seagrass. And in this ideal world, community seagrass monitoring projects would spring up everywhere as a key part of protecting this ecosystem. We are on the right track here in Broome. And it is the good people of Broome, our local volunteers, our dedicated, hard-working, good-hearted local volunteers that enable this most valuable of monitoring projects to thrive. We're on the right track here in Broome. We are leaders in this area, saving our seas by saving seagrass. You've been a beautiful audience. Galia, and thank you.